Okay, I'll explain the first experiment. Actually, we are supposed to do the CE configuration, but because of the meter availability, we are going to explain the common collector configuration. Okay, this is going to be the circuit diagram, and the transistor used is going to be NPN transistor, and you have to connect 2 meters, that is ammeter and a voltmeter. Always the voltmeter should be in parallel and ammeter should be in series with the circuit. And here for the ammeter, that is from input side, for the ammeter we have to use a microampere ammeter, but while giving the we don't have a microammeter, that's why we are using a milliammeter. Then in the output side, again we need a ammeter and a voltmeter. The ammeter is going to indicate the emitter current, and the voltmeter in the output side is going to connect it between collector and emitter, so VCE. And similarly, the input side, the voltmeter is connected across B and C, that is base and collector. So therefore our collector is going to be common with the input as well as with the output. That's why this is common collector. So the procedure is, we have to change, we'll be connecting 2 RPS, regulated power supplies. While doing the input characteristics, we have to keep the VCE at constant positions, and we have to vary the RPS1. Let me call this is RPS1. We have to change the RPS1 in steps, and corresponding VBC and IB values have to be noted down. And this has to be repeated for second set of readings. Okay, not only ஒரு single set மட்டும் இல்லாமல் second setக்கு நம்ம இதை பண்ணணும். Second set in the sense VC, suppose first வந்து we are going to keep it as VC value is 2.5 volt. Now next time we are going to keep VC as 5 volt. So this is called as set of reading. Okay, and first setக்கு இப்போ VC is kept as 2.5 volt this side, right? Then you have to change from the beginning, you have to change the from 0 you have to increase the voltage, but you will be getting the microampere current at if the voltage is reached the cut-in voltage. If it is a germanium transistor, that is 0.6 volt. Silicon, in the sense, that's going to be 0.6 volt. Okay, that you would have studied in theory and all. What is the cut-in voltage for germanium and silicon transistors? Okay, 2 sets of readings. Then for output characteristics, what we are going to do is, you have to keep this IB constant at some position. So what is the position we are chosen is 20 microamperes and 40 microamperes. Okay, then keeping this IB constant, then you have to change using this RPS, you have to change this VCE, and corresponding IE has to be noted down. Okay, so this is the procedure, and this is the model graph. Finally you are supposed to draw. You'll be getting this kind of graph. In the next video I will explain how the readings have been taken. Okay.